All right, so as Eric mentioned, I work for Duo Security, which is a two-factor authentication company. So I'm probably going to be talking in a bit of a different direction from most of the other people here, because in particular, what we spend our time thinking about is kind of how we can get away from using passwords, or just using passwords. And this is an opportune time to be in this industry because this has become something of a manifesto, right? Maybe you guys would not be too happy about this, but especially when Wired made this their cover story. I think this was from December. This was Matt Onan's follow-up to the story about how he got horribly breached, saying, wow, we need to fundamentally rethink how we're doing authentication. And this terminology, at least since then, has become very prevalent in the media, at least. And you find random things like this. There's a petition online against passwords. I'm not entirely sure who we're petitioning. Maybe it's us actually. But
do you have to log in and give a password to sign up?
I don't know that. Maybe they use Facebook Connect or something. So what I'm going to do today is talk about a couple of case studies that I've run across where there are arguably attempts to move past using passwords or just passwords, where it's turned out that this isn't as true as we would like. And then I'm going to try to draw some more general conclusions from this and with an example of one major player who seems to be on the right track. So the first case study is some work that we did earlier this year on one way that you could bypass the two-factor authentication that Google put into place. So it was a couple years ago that Google rolled out two-factor authentication to all of their users, and this probably still to this day is like the biggest consumer-facing rollout of two-factor authentication that anyone has ever done. And in a lot of ways, it was great for those of us who believe two-factor authentication is a good idea because it put it in front of a lot of people who otherwise might never have seen it. Before this, it was kind of reserved for enterprises, paranoid companies, security experts, and people who played World of Warcraft. But, so as part of this, they actually came up with some kind of cute marketing materials about the two-factor authentication means that the robber has to get past the barrier and escape from the same bit rather than only having to do one of those two things. But they also kind of implemented a backdoor. And, okay, so to review, I'm kind of guessing a lot of you have seen this already and use it, and if you don't, I would claim you probably should. But, it's basically you go to log into some Google website, enter a username and password, and then you get prompted for a one-time passcode. This is either going to be generated by a mobile app on your phone or sent to you over an SMS, and depending on what you configured ahead of time. And that's great, but Google also supports a lot of other random things. They've got support for various protocols to access various things. You can use IMAP and SMTP for Gmail instead of logging in via the web. You can use CalDesk to sync iCal or whatever. You can use XMPP to sign into your Google Talk account. Well, they call it Hangouts now for some reason, whatever. And I think this list probably goes on, although those are the examples I came up with. It was also the case when they launched this that Google had a whole bunch of their own kind of, I'll say, thick client software. And you can understand that for a company as big as them with as many different units, getting everybody in sync at the same time to roll out a new authentication method to everyone the right way would have been virtually impossible. So at least as an interim, they had to come up with something that was an interim solution that would work with existing versions of things like Android and Chrome. Oh, and of course, Android also has this 2-year lag before you can actually expect anyone to be running what was the latest version. So even if the company had their ducks in a row, that wouldn't help. So they came up with this notion of application-specific passwords. And this, again, I'm expecting many of you have seen this, but if you want to use one of these kind of legacy systems or thick clients where two-step verification won't work natively, you log into the account settings portal and you tell it, I want to generate a new application-specific password. It generates a 16-character lowercase password, tells you to basically copy and paste it into whatever you want to use it with, and then forget it for all time. You're only supposed to use these in one place, and they are all individually revocable, which, okay, that's like this. They're all individually revocable, which is kind of nice if you actually come across a situation where you think you lost something and no one has actually used it to break into your account yet. You can revoke that individual password without breaking your ability to use everything else, instead of having to reset all of your stored passwords everywhere. It's a little bit convenient. So, seeing this model, it sort of looks a lot like something that's fairly common. It looks sort of like what you're doing if you set up a service using OAuth. The main difference is that with OAuth, it's also providing or pushing you towards writing a workflow where users don't have to do this by hand. They just sign into a website and get redirected, or get a web view or something. You log in right there, and then it does the negotiation behind the scenes to get itself a long-lived token it can use to do whatever it wants. In this case, ASPs are a little bit cruder. You have to do it by hand as the user. You have to copy and paste, or whatever. The other thing is, it turns out that in spite of the name, application-specific passwords are not, from an enforcement perspective, application-specific. And Google was fairly open about this. They wrote some paper in an IEEE publication where they were talking about how they did this massive two-factor rollout. And this is a quote from there. They did say this was the case. So, okay. So, right. From what I said before, you can use, given that, you could use, if you had an application-specific password you were using for your email client, you could copy and paste it into your calendar and it would work. You could copy and paste it and use it to sync an Android device to your account and it would work. All right, well, all of that's fairly expected. But what's more interesting is that starting in, well, I first saw this in Android 4, they introduced a feature where if you have your Android device synced to a Google account, then when you go to actually sign in to something, mobile web, whatever, it prompts you. It says, hey, do you want me to automatically log you into that thing? And so if you touch that little sign-in button, then it takes you right past the username, password, and the two-step verification prompt. So you're in. You can do whatever you want. And this works anywhere that there was the standard Google account login prompt. Really interestingly, it worked for even the most security-sensitive parts of your Google account settings portal. The two examples being the page where you go to control your two-factor authentication settings, turn them off, generate additional application-specific passwords, whatever, and the page where you go to change your account recovery settings, in particular things like the email address used for password resets. So with that second one in particular, here's what we've got. If we put these pieces together, you can take any application-specific password anywhere, link it to an Android device, say, and then use the auto login feature there to get you into the account settings portal, change the password reset email address, turn off two-factor authentication, and there, at the end of that, you've completely owned the Google account using nothing but an application-specific password. You bypass the two-step verification process. So I was able to figure all of this out just by like poking my phone and going to these pages and saying, hey, that worked. Surprise. I don't think that's good. But I decided we should spend some time and actually dig into sort of API protocols that they're using. So it's kind of an aside. Doing HTTPS interception on your own devices can be an extremely valuable tool in figuring stuff like this out. And it's not particularly hard. The first time I tried this, I was using a real device, and I set it up, went into the advanced network settings, set a custom default gateway pointing to a Linux box. This means you don't have to do any ARP spoofing if you don't want to, if you think other people in your office will get mad at you for doing something like that. And then on the Linux box, running SSL sniff, and just create my own custom CA certificate and install it on the phone, which these days is quite easy. There's this, because a lot of enterprises actually require you to do this sort of thing, you just need to stick it on the phone's storage partition, go into the security settings and say, hey, install this certificate. Okay. I eventually figured out it would be much easier to use the emulator, because the emulator actually has a flag that lets you say, send all the traffic through an HTTP proxy. And with that, you could use the burp suite proxy. It's got like a much SSL sniff, which is a command line program that dumps its output in sort of a raw form. So whereas burp proxy, well, it looks like this. So you get a list of all the requests, tabs, nice, the request, the response. And it's really kind of much easier to go through the information and see what's actually happening with something like this. So okay, what do we find? There are a couple different workflows on exactly what the sequence of requests was, but this was sort of the simplest one that we came up with. Basically, first, when you link your phone, when you give it a username and an application-specific password to sync to your account, send that post to that URL, your email, a field that says encrypted password, and service equals AC2DM. So C2DM is cloud-to-device messaging. I'm guessing based on that, it's the push service for Android. It probably incorporates a bunch of other things internally. So from the context, I'm guessing that this is basically saying the service is unlocking my Android phone. And you get back a response that contains one field that's called a token. Then the next thing that happens later on, when you're going to do an auto login to some site, it sends a post to the same URL. This time it sends email, your token, and then the service parameter is quoted. It's web login, :continue, and then whatever URL you want it to take you to after you're logged in. And then, in the response, you get this long URL with a bunch of stuff in it. And if you open that URL in the browser, then you're instantly logged into the account. Just in a bit more detail, this is the first step. There's some other stuff in these requests. Most of it, as far as I could tell, didn't matter that much, or was pretty static. Get a response, got a bunch of stuff, including that token there. Oh, and so this encrypted password thing was a bit confounding, but it turned out that this API looks a lot like something that Google actually does have publicly documented called client login, which is kind of what you were supposed to use for any form of API access. I think they've been working towards deprecating it now in favor of some other things. But anyway, the documentation for that included a clear text password parameter rather than an encrypted password parameter. So instead of trying to go in and figure out what the encrypted password actually, how it was generated, just said, why not substitute that with a plain text password parameter containing the application-specific password, and that worked. And then the second request, again, you've got email, the token returned by the first request, and the service that contains the URL you're trying to get to. And it gives you back this. pass.google.com/merge session with some arguments. The continue parameter is, again, that same URL encoded into it. It's got an uber-auth parameter, which is an extremely long opaque token. And then, like I said, when you open this URL, you get logged in. And finally, I said, well, okay, those two calls look pretty similar. What if I just try replacing the token in the second one with the password for the first one? Yeah, it works. So at this point, yeah, we can basically go from having an application with a sensitive password to having the ability to fully take over your account with one API call. And, well, let's do this for a second. So I've got this pretty dumb Python script that I wrote to call this API function and some credentials. By the way, this account is not one I use for anything, so I still appreciate it if you don't do anything with it. But it shouldn't matter.
Just want to say that password has now been added to word lists across the globe.
I'll revoke it as soon as I'm done with this presentation. That still gives you like, 30, 40 minutes. All right, so if we run this, okay, right, I've got a Chrome, window, no cookies.
I think you might actually be GApp's admin for that domain. If I have accidentally made you an admin for that account. So.
Oh, you shouldn't have done that. Let's see. That worked. Oh, that's right. I'm asleep. I'm really not big enough to actually see them. Just do this like that. It's okay, one second. All right, so, login page. So if I run this script, it spits out that output as I did in the slides. Copy that, paste it into the URL bar here, and I'm logged in. Go to whatever, Gmail or all right, so this happened a while back. In fact, it was a bit over a year ago that I first noticed this might be possible. And we had some back and forth with Google security team. They said at first that it was a kind of expected behavior of their design. I think they also told us at the time, yeah, we realized this isn't great, we might fix it sometime in the future. And so last February, it turned out they actually did make a fix, at least for some of the most the egregious bits of this. I'll get to that in a second. And we rapidly followed up with a blog post on it right before the RSA. So what Google actually did was they made it so that the most sensitive account settings pages, the ones that I was talking about that you could use to take over an account completely, are no longer accessible via the auto-login feature. If you try to go to those, even with one of these merge session URLs, you get a prompt. And you can generate another URL, try again. You won't get past this unless you actually enter your password and go through two-step verification. So that's...
You could read all the Gmail, right? You could read all the Gmail. Right?
Yeah.
So somebody last night at a party was saying, that's why it's a really good idea to have two-factor authentication on the email address you use to send all of your password reset emails to for other.
Yes.
Well, so much for that.
Yes, all the
I would say-
time.
Yeah.
And the other part is you need to be very, very careful with your use of the applications that are passwords,
Yeah.
because they are very dangerous.
I am getting to all of that. So the thing about this is that's the only change. Nothing else has changed. So yeah, application-specific password that you were using for something that seemed unimportant can be used to read your email. Oh, and I should mention a few other people came across the same notion. I think of all the ones I saw, we went into the most detail on exactly what's happening under the covers, but there were other people who noticed this, which is good, right? It means people are paying attention. Because to me, this wasn't that hard to notice. All right, and there were some further conversations afterwards that I thought this exchange between Moxie and Matthew Green did a great job of framing discussion around this by saying, this does solve some problems, but, it's amazing how many problems you can solve by limiting your threat model. And of course, I can be guilty of saying things like this myself, unironically, but this is a case where we could do better. So yeah, turning on this feature and using application-specific passwords the way they're intended still helps with a lot of the sorts of attacks that we've been talking about here at this conference. They're all randomly generated. You never share them across different sites. Again, if you're doing what Google tells you to do. And if you see something like a phishing attack that says, give me one of your Google application-specific passwords, I'm guessing this would be way less effective because you've got like the smart people, the savvy people, and the clueless people. The clueless people would say, what's an application-specific password? The savvy people would say, no. That's my guess. I have no evidence to back this up. But there are still a lot of ways that this could go wrong. For example, HTTPS command in the middle. Now, browsers have been ratcheting up this scare factor more and more about what happens when you receive an invalid certificate. But browsers aren't the only things that use SSL. And one real problem out there in this world is that a lot of other software does a really bad job of this. In fact, if you go search on things like Stack Overflow, or developers asking, I'm getting all these weird certificate errors in my code, other developers saying, no, just turn it off. And a lot of other people being like, yeah, good idea. No, it's not a great idea. And then it's also worth thinking about when you're doing, say, passwords, which is essentially what Google wants you to do with application-specific passwords, store them in your program's memory, look at them again. It's worth considering how is this actually done. On Windows, the kind of canonical way everyone does it is using the API called the Data Protection API. What it does is it encrypts data using a key derived from your user's logon credential. So, the idea being that someone might yank the hard drive out of your server or desktop, they wouldn't immediately be able to read that data. Now, maybe if you crack the SAM database and crack the MTLM caches, this would be defeated, but that doesn't even matter to me because the threat I'm thinking about is if you get tricked into installing malware on your computer, if it's running under the same process, the same user ID as the process that stored this data, it can just be crypted. No questions asked. And if you look at something like the keychain on Macs, the design seems a little bit more robust because it does per application authorization. And of course, you've got a lot of programs out there that still just store things in plaintext. For example, Pigeon. Now, they have this whole discussion on why they store things in plaintext. And actually, I would like to pull that up and read. They say, instant messaging is not very secure, and it's kind of pointless to spend a lot of time adding protections onto fairly strong file protection units, and the protocols themselves aren't all that secure. That's it. Secondly, you shouldn't be using your instant messaging password for anything else. While some protocols have decent password security, others are insufficient, and some, like IRC, don't have any at all. So they're basically saying, like, among other things, that usually your instant messaging passwords are not things that you should really care about protecting. But if we're talking about application-specific passwords for Google services, well, very different story. And this is exactly the example we were just discussing. The impact of compromising your IM passwords, probably not that big. Annoy your contacts, maybe pull out some social engineering attacks if you really want to, spend some time targeting the same person. But Gmail, it's not unlikely that that's the password recovery mechanism for everything else you do on the internet, so that could be really bad. And so, also, recently went back and revisited some of this, looked a little bit more into this auto-logging feature, because it turns out it exists on desktop versions of Chrome as well. I mentioned this before briefly, but Chrome on Windows, Mac, Linux, this feature still exists. It's just disabled by default and hidden. You have to go to Chrome://flags to turn it on. Chrome, interestingly enough, they have moved completely past application-specific passwords. They now use a fully OAuth 2 workflow when you're signing in and enabling bookmark and tab synchronization. And that's the feature that that's getting passed on. If you turn on the bookmark and tab synchronization feature, then you can use auto-login. See, it says auto-login is always disabled if the profile is not connected to an account. So I'm not going to get quite as much into detail on this one, but basically you have a somewhat similar workflow. You first take your long-lived OAuth token called a refresh token and send it to this URL to get back a temporary access token. Then you take that access token, use it to get this UberAuth token that I was talking about before, and the UberAuth token is pretty much all you need to construct one of these merge session URLs to take you wherever you want to go. Oh, and by the way, the refresh token is stored in plaintext. So, I was talking earlier about how OAuth and application-specific passwords are a bit different. One of the things I said was that OAuth tends to imply that you might actually be using some more application-specific authorization policies. Well, if you get those policies wrong, it won't save you. So again, just like the sort of Pigeon versus Gmail case, I think this is kind of, the problem is, to me, that this is an unintuitive threat model. You sign into Chrome, it's storing some credential somewhere. You think that's only used to sync your tabs and bookmarks and history and whatever else. Okay, fine, whatever. And especially because this is a hidden feature that's disabled by default, you probably don't realize it exists. But it doesn't matter because the credential that Chrome is storing can be used to do this, whether you turn it on or not. So now for something pretty different. You all probably have a pretty good idea of what pass-to-hash attacks are in Windows, but I'll go through a real quick review. If you have a Windows network, you have a domain controller, which is kind of the central point of authentication for everybody. You also have individual machines, and you can have accounts in both places, both centralized in the domain and on individual local machines. And either way can be an administrator on a workstation. If you are an administrator on a workstation, you can do whatever you want to that workstation. Read out the memory, read anything from the disk. Full control. And Windows networks have a whole huge slew of authentication protocols. The two most common ones to talk about are NCLM, the authentication protocol, and which is different but related to NCLM, the hash function, and Kerberos. And Kerberos is kind of what Microsoft is gradually pushing everything to, and has been for the last probably more than a decade. But NCLM still exists. So just to MTLM is a challenge handshake style protocol. It's like, you get a challenge, you can compute a MAC over that challenge, and send it back. That's sort of the idea, at least. The funny thing about MTLM authentication is that instead of using your password as the input, it uses your password hash. So for any protocol that uses, for anything you can do in a network that uses this authentication protocol, you do not need to know the user's password, only the hash. And this protocol is quite pervasive, and you can do some pretty insidious things with it, like run processes on other computers, connect to file shares, as long as these aren't firewalled off, which if you have a smart network admin, they might be firewalled off. But so, this is kind of the model that people talk about when they're doing pen testing on Windows networks, is you gain a foothold somehow. Maybe you drop some malware by tricking some unsuspecting user into clicking the wrong link, or maybe you compromise one password by some other means, whether it's phishing or cracking or whatever. You extract the hashes that are present on that workstation and use them to move laterally through the network until at some point you find a hash you can use to compromise the domain admin account and take over everything. So when I was thinking about this, from a perspective of wanting to use stronger authentication, it occurred to me that Windows does support smart card-based authentication. So smart card, or you can call them PKI tokens, sometimes you might call them HSMs, although that usually implies something a little different. It's a piece of hardware that has some memory and some computational ability, and it has a very kind of restricted interface, both in software and hardware, of what you can do to talk to it. So the idea is that the private key, the secret that's stored on this device, can never be extracted. Instead, all it will do is compute things for you. Say, I want you to sign this value, or I want you to decrypt this message. It will do that, but it will never, if you say, I want the key, it doesn't even understand that notion. It can't happen. I put never in quotes because it's very easy to make very small, subtle errors in the way that you implement your crypto that make it so that this is suddenly not true. And there have been some examples of this over the last few years. A bunch of vendors of smart cards and PKI tokens actually got their stuff kind of broken, but not everybody did. The idea still could theoretically work. It's just theory and practice don't always match up. And so Windows supports this. You can set up your network so that instead of getting a username and password prompt, when you log into a workstation, it says, plug in your smart card. So that sounds much better, right? Because in this case, your secret that you're using for authentication is only stored on one device. It can never be copied anywhere else. This whole idea of password hashes should just be moved, right? Well, so I was reading, I haven't done anything more than just read some documentation about this, at least so far, but I found this little paragraph in one of Microsoft's specs. It says, in order to support MTLM for applications connecting to network services that don't support Kerberos authentication, when you use this protocol, which is basically, as far as I can tell, it's some extensions to Kerberos that Microsoft made so that you can use public-private key negotiation in the initial set of messages. It's saying the KDC, which is basically your KD server, returns the user's MTLM one-way function, which is another way of saying your MTLM hash in some section of this protocol. So here's the thing. Because MTLM is still pervasive in Windows networks, the MTLM authentication protocol, even if you're using smart cards, Microsoft still has to support the case where where your workstation needs to use MTLM to communicate with some other service. So even though you have developed a network layout and authentication policy that nominally doesn't use passwords at all, internally passwords still exist and can still be used to do things. So again, this helps with a lot of the same cases because it kind of takes it somewhat out of the hands of users to screw up. I think I've heard from talking to people who've worked on crypto hardware in these sort of environments that best practice when you're using a smart card deployment in a Windows network is basically to go in and set every user's password to some random value that's never stored anywhere else. So that'll help with weak passwords or shared passwords between different accounts. And the second case is important because that's often how fast the hash attacks succeed, is because like one of your local accounts use the same password as your domain account. But there are other ways that Windows caches these password caches. So if you compromise the workstation and the domain admin logs in or has logged in somewhat recently, you can still extract their NCLM hash and use it to do bad things on the network. So I'm going to try to draw some more general conclusions from these examples. And I don't think anything I'm going to say here is extremely novel. In fact, if I had come up with something very novel, that would have bothered me because a lot of other smart people exist in the world. But at the same time, even if it's not novel, I also think that these are some examples. You know, there are many more of people, very smart, savvy companies, not getting things right or not getting things as right as they could. So it's still worth going through this exercise. And what I've come up with is that, you know, if you have a real world ecosystem, it's going to have some complexity and it's going to have a lot of variation in the ways that users or clients will authenticate. And that passwords, for legacy reasons and for convenience, they're probably going to continue to exist for, you know, indefinitely, basically. And so in order to deal with this, we have to really carefully balance what privileges are granted for individual sessions or API requests or whatever with how much trust we have. And to be a little bit more concrete about trust, I'd say we need to look at two things. One is rights, which is fairly obvious if you're talking about authorization at all. It's what is the set of permissions that should be granted to the user. But there's also the notion that I'm going to call integrity level, which is saying how strongly has someone authenticated. Did they use a password? Did they do a password with multi-factor authentication? For the multi-factor, was it an inbound one-time password or some kind of awesome out-of-band protocol? Or did they use, you know, SSL clients or, you know, lots of different possibilities with different characteristics on how likely it is that an attacker could screw with it. So basically, I guess what I've ended up doing is I've come up with a talk about authorization at a conference about passwords, so sorry about that. And what I'm going to do last, before giving up the podium, is go over one example of something that I think has been done pretty well, at least in the context of what they're trying to do. That's the identity and access management system in Amazon Web Services. So they have this system where, you know, you sign up for an Amazon account, you create a username and password, whatever. But once you've done that, you can create other users within this account. And then you can specify what those users are allowed to do by a really flexible rights expression language, basically, you know, some JSON dictionaries that they have you write. And the primitives that you're using to build up these rights are resources, which for EC2 could be instances, for S3 could be buckets, maybe individual files, I'm not sure if it's that granular. So DNS zones and Route 53, I mean, it goes on and on. And then actions you can perform on these resources, like starting and stopping or terminating, deleting files, you know, whatever. And then also some other session context is exposed, like your client IP address, whether you're connecting over SSL. Some of the older APIs actually allow you to make requests without using SSL. That they have some signature format that should make that okay, maybe, but pointed out it's better to use SSL. Whether you use two-factor to authenticate a session, and also some day and time type questions. So, for example, you can make this policy and attach it to a user, which says that this user will not be allowed to stop or terminate an EC2 instance unless he is performing this action somehow having done two-factor authentication. And even cooler, in my opinion, is the fact that they made it so that you can make your own API clients offer a mechanism for people to do two-factor authentication. Basically, you have a set of long-lived credentials, an API key, and a secret. And you make a request to their secure token service with these credentials, and then also with a one-time passcode that the user generated on his phone or hardware token. And assuming it's successful, this API returns back a new set of temporary credentials that you then use for authentication to the other APIs. These credentials expire. I think it's configurable time window. You can make it as long or short as you want. And so, this is cool. This basically allows you to do everything that I said. The only problem is that Amazon leaves it to us to actually define these policies in a way that works for us. Now, for AWS, this is probably the right choice, because AWS is intended mostly for developers or other people who have some idea of what's going on. But if we wanted to apply the same notion back into something like Google, I don't even know how you would start with that, because they have to support both people like us and people who have very little idea of what's going on. So I'm not really sure how you could actually build a user experience that would work for the sorts of regular people that Google needs to support. One idea would be maybe they could do something like trust on first use with application-specific passwords, where you use it to connect to INAP, and then it'll only let you ever connect to INAP with that credential ever again. But I don't know. Besides that, there are all kinds of complications with rolling out a policy engine across your organization like that. But anyway, I think that's about all I had. So if there's time for questions, I can try to answer them.